In today's note, we are going to be looking at the present value. So in interest in saving money, we may have an end goal in mind. It may not be, I want to know how much I have in the future. It may be, I know how much I have. How much do I need to start with? Usually when we're saving money, we have a goal in mind, right? We have something that we want to purchase, right? Whether it be a car, whether it be a house, whether we be saving for school, or maybe it's just kind of a luxury item, an expensive computer, a gaming system, a new coat, whatever it may be. We know how much we want to have in the future. We need to know how much do I need to start with, or how much do I need to put into my account to start saving so that I can have that in the future. And if that situation comes up, we're looking for the present value. And that's what this formula is here. It's the same compound interest formula that we looked at in the last lesson. It's just rearranged. So again, this is, rather than have you rearrange it every single time, we're just going to start off with it rearranged and then go through and then plug in our information and solve. Similar to compound interest, the variables mean the same thing, and we still have to calculate an I and an N value before we can actually use the formula. So the present value formula, we can see that here, P equals A divided by 1 plus I to the power of N. So hopefully you can see the comparison or the similarities, right? It's the same variables as the compound interest formula, so everything should look familiar. A is the total amount of the investment or the future value. P is the principal or the present value of the investment. I is the interest rate as a decimal per compounding period. And N is the total number of compounding periods. So again, same meaning as before. In example 1, calculate the amount of needed to be invested today in order to have $5,000 in 4 years if the investment is compounded monthly at 3%. So, looking at this question, we still have our A, P, I, and N on the side to fill out. Let's go back and highlight some important things. The first thing that's important is the amount needed to be invested today. And this key thing here is the today part. Because knowing how much we need to invest today means we're looking for the present value. As we continue to read through, we need to know how much we have in order to have $5,000 and in 4 years if the investment is compounded monthly and then at 3%. So going back and looking at this, we have our key information. We can now fill it into our variables and then go from there. So the A value is the future amount. In this case, it's $5,000 because that's how much we want to have in the future. Our P value, we don't know because we're talking about the amount needed to be invested today. The I value we can calculate. And again, remember, we do have to calculate it. So we start off at 3%, and we're going to divide that by the compounding period, which in this case is monthly, which means 12. So 3% or 0.03 divided by 12 equals 0.0025. And then our N value, it's 4 years times 12 months in a year equals a total of 48. From there, now that we have everything filled in, we know what we're looking for, we can use our present value formula. So P equals A divided by 1 plus I to the power of N. A equals 5,000 divided by 1 plus 0.0025 to the power of 48. And again, this just becomes a calculation now. If you want to do it in steps, I recommend splitting it up if you're not comfortable using your calculator. So it becomes 5,000 divided by 1.127. And try to keep a few decimal places, and then which equals $4,435.27. So therefore, you need to invest $4,435.27 today. The second part of the question is asking how much interest would the investment earn? So what we have to do, if we're still going back to that small little calculation of the A equals P plus I, where A is the total, P is the principal, and I is the interest. So if we're looking for the interest, right, the interest is going to equal, in this case, it's going to equal the future amount minus the principal. Right? How much you have in the future minus what you started with will equal the interest. So we go through and calculate. Our future amount was $5,000, and we're going to subtract how much we start with. In this case, we were told we need to start with $4,435.27. So when we do that calculation, we get an I value or an interest of $564.73. So therefore, the interest is $564.73. So again, just a small calculation to figure that out. In example 2, John has a loan of $4,000 that is due in 3 years. He wants to pay his debt early. The creditor is willing to discount his loan at an interest rate of 8% per year, compounded semi-annually. How much would the creditor be willing to accept as a down payment today? So I'm going to start out with my A, P, I, and N, because I know we're dealing with compound interest because it mentions compound. And let's go through and find some information that the question gives us. So he has a loan for $4,000 due in 3 years. We know the interest rate, compounded semi-annually. And how much would he be willing to accept today? So again, today is that key phrase, because that means that we are looking for the present value. So now going back, that means 4,000 is what we want to have in the future. Our present value, we don't know. The I value, we know the interest rate per year is 8%, but I'm going to divide that by 2 because it's semi-annually, is my compounding periods. So it's 0.04. And my N value is 3 years times twice a year, which is 6. I have all my information, so I can go back to my formula and using the present value formula and fill in my information. So 4,000 divided by 1 plus 0.04 to the power of 6. Again, if you want to separate it, do it step by step. The calculation, it should be 1 divided by 1.265 rounded, and we should get $3,161.26. Again, depending on what you round by, it may be off by a little bit, but as long as you're within $5, that should be you should be on the correct step. If you're more than $5, I double check your calculations and then just double check your rounding. So therefore, the creditor will accept $3,161.26 today. So in our last example, Maria wants to invest enough money today to have $10,000 for tuition in 4 years. If she can invest her money at 6% per year, compounded monthly, how much does she need to invest today? So I know I'm looking for, again, A, P, I, and N. So going back to my question, wants to invest enough money today. So again, that tells me that today part tells me that I'm looking for the present value to have $10,000 in 4 years. So that means my future value is 10,000. 4 years I'm going to use in my other two parts. 6% per year compounded monthly. So for my I value, I take the 6% divided by 12 for monthly. 0.005 is my I value. And then for my N, it's 4 years times 12 compounding periods equals 48. So from here, I can just start with my formula. P equals A divided by 1 plus I to the power of N. I have $10,000 divided by 1 plus 0.005 to the power of 48. And I'm just going to jump right to the final answer for this one. $7,870.98. So therefore, Maria should invest $7,870.98. So these examples we're looking at the present value formula. Again, remember, it's just the compound formula, just rearranged to look for the present value. So this is where if a question is dealing with compound interest, but it's asking you for how much do you need today, or how much do you need presently, how much do you need now, right? Read the question carefully, so you're going to be looking for those key phrases. But once you do that, the steps are the same as compound interest. You're just plugging it into a slightly different formula.